As Katarina said, my talk will be about how you can create, using the Intel Edison kit that you have, your own HomeKit accessory. So I'm just going to go over basically what HomeKit is all about, and then we're going to do a little live coding, and we're going to transform this thing into a HomeKit-enabled LED light bulb. So first, a little about me. I'm a former iOS jailbreaker, and jailbreaking is like similar to rooting on Android. What we do is we enable people to make modifications to their iOS operating system on their phones, even if Apple wouldn't ordinarily let you do that. And now I'm a security researcher at a small security firm called Azimuth Security in Australia. And I'm also a huge home automation enthusiast. So this talk is sort of like all these three things melded together. So what is HomeKit? HomeKit is Apple's home control and automation platform. It's kind of an amorphous thing. It's not just an API. It's just not just an SDK. It's several things. And it's you can think of it as an ecosystem. And one major part of it is it provides one standardized way for accessories, which are the things in the Internet of Things, to talk to iOS devices. And it also provides one standardized way for iOS apps, even third-party apps in the App Store, to talk to those accessories. So why would you make a HomeKit accessory? Why would you want to integrate with HomeKit? Well, you get a lot of benefits from doing that in the iOS ecosystem. One thing you get is integration with the iOS Control Center, which you can access anywhere in iOS just by swiping up from the bottom edge of the screen. And since I'm a home automation maniac, I have so many accessories. And this for my Control Center accessories, I just put the most often used lights and also the alarm system in the house. Another thing that you get is that you get integration with the existing scenes that your user may have set up. And a scene is just a way to control multiple accessories at the same time. So iOS includes certain default themes like good morning, arrive home, leave home, good night. And like one example of what I do with my scenes is that when I tap leave home, that'll turn off all the lights in my house at the same time, and it will also arm the security system. And I'm not going to go into separate apps and turn on each of the lights and go into another app for the security system and turn that off, but I'll do it if it only takes me one button. So finally, and this is all done in the iOS Home app, which they provide with HomeKit. Finally, what you can do is you can have some built-in automation. For example, in my house on the weekends at sunset, we have it set so that the lights in the bedroom come on, but the bedroom blinds also go down. So all of this, to summarize, you get all these features, and you don't have to program any of it. You just have to integrate your device with HomeKit, and you get all of it for free. And also, users don't need to use an extra app. I know I hate downloading apps. So this will just make it easier for them to use the accessory that you create. And if you have something that's easier to use, people are more likely to use it. And that lets you control. That lets you save energy. So, for example, you're not using the lights or any of your accessories while you're gone. So that's a major benefit. So there's a couple of different protocols and APIs within HomeKit, but we're going to concentrate on the HomeKit accessory protocol, which is what you want to be implementing if you want to create a HomeKit device. So the HomeKit accessory protocol is not its own radio protocol. It doesn't define any physical packet radio or anything like that. It's actually layered on top of Wi-Fi, actually technically TCP/IP, because you can have a HomeKit accessory that operates over Ethernet as well, or it can work over Bluetooth. And it looks a little bit like HTTP, like a REST server. So basically, if you create your special combination MP3 player and light bulb or whatever, the iOS device, the iPhone or the Apple Watch will be talking to that device as if it was a HTTP server, a little bit. And the protocol also has really nice and strong encryption. It's probably the best encryption I've seen in the home automation industry. One major downside is it's completely closed. So the only things that we know about the protocol we got from reverse engineering it. So in order to use this protocol, we have a few vocabulary words. There's only 3 of them, but if you don't kind of get it right away, it's okay, because I'm going to go into an example in the next slide. So each of the IoT, each of the things, each device is an accessory. And each accessory has many services. And each of those services has many characteristics. And the characteristics are the things that actually do stuff. Like you can read from them or write to them. And if you read from them, you'll get the state of the device. And if you write to them, you'll be able to change the state of the device. So one example that we're going to create right here is the Women Who Code LED light. And it's very simple because all it does will turn this blue LED on and off. And it has, so the accessory in this case would be the Women Who Code LED light. And it has one service, which is light bulb. And it only has one service because it only does one thing. It doesn't do a combination thing. If it was a combination light bulb video camera, then it would have 2 services, light bulb and video camera. But it only has one service, light bulb. And it's a very simple light bulb. It can't change color. All it can do is be on or off. So it has one characteristic called on. And you can read it to check if it's on. And if you write onto it, to that characteristic, you'll turn it off. And if you write off to that characteristic, you'll turn it off. So how do we make this with the Intel Edison if the HomeKit accessory protocol is closed? Well, we can use this open source library that people have created from reverse engineering HomeKit called HackNode.js. And you're not even supposed to know anything about the HomeKit accessory protocol unless you join Apple's MFI's program. But this is actually pretty, so you can't release what you make commercially, but you can still use this to prototype something. And if you decide that, hey, this is a really neat idea, you can always join the program later. And since you can guess from the name, HackNode.js, it relies on Node.js. And also we're using Intel's extremely excellent MRA library, and that makes it all really easy to plug in. It's actually like one of the easiest IoT libraries I've ever used, so thank you. So this is sort of the hardware setup. I know you guys can't really see this very well, but here's a picture of it. Basically, we have the LED plugged into D2, right? It plugged into the D2 pin on the Grove board. So we have the Intel Edison itself that's on the Arduino breakout that has a Grove board plugged into it, and then in that D2 pin, it plugs into the LED. So that's the hardware setup, and now we're going to show you the software. So the first thing you need to do is you need to download HackNode.js. So just go to this site, and I'll give you the URL later, and just download zip. And then you have to unzip the file. And then you can go into Intel's XDK program and create a new project and import that folder that you just downloaded. So it's already selected, so I'm going to press select. And then we just can call it So one thing we want to do here is because this HackNode.js is actually designed to be used in another project called Homebridge, we actually have to modify the package JSON a little bit to set the main script from index.js to core.js. So that's the first thing we need to do. And then we also need to delete some of the example accessories that they have, because leaving those in will cause it to create a lot of these example accessories that don't actually control anything real. And we'll delete every single one of these files except for types.js. And now I'm going to do something else. I'm just going to connect to the Edison and sorry, I gotta. This is actually going to be really difficult. I didn't think this through.
You can use this.
Yeah. Okay, so can everyone still hear me? Okay. So I'm gonna log in, and I'm going to upload the file, the project, to the Edison, because the reason why I'm doing this first is because it actually takes a little while to upload. So I'd want to start coding while I'm doing that, because HapNode.js has several dependencies that need to be compiled, and that takes a little bit of time on the Edison. So while that's happening, I can create a new file under accessories, and we just can call it women code LED light underscore accessory.js. And the last part of the name is actually significant, because that's how HapNode.js knows what to load. So first we are going to write some boilerplate. We need to start importing some libraries from HapNode.js. And actually, let's do this first. One of them is the UUID generator, because each accessory needs their own UUID. Another thing is, as I recall, there's 3 different types of objects in the in the Hap world. One is the accessory, one is the service, and one is the characteristic. So we need to import those classes from HapNode.js as well. Service. So now we have everything we need from HapNode.js. Now we just need to load the MRA library. And that's actually significantly easier. And notice I didn't have to edit the package.json for the MRA library. This is because the Edison has that library installed globally, so we don't need to do anything but require it here. So the first thing we need to do is to create the accessory itself. So we need to put the name of the accessory here, and then we need to generate a UUID for it. So this UUID is going to be common for all accessories that all WWC LED lights, but there's a separate identifier called the username that identifies the particular accessory. And that's like a MAC address. Like every single router has a different MAC address. So technically every single one of WWC LED lights have to have a different username. But but that doesn't actually need to happen in practice. So we're just going to make one up. And then we also need the pin code. When a HomeKit accessory is paired through iOS, it needs a pin code to make sure that there's nobody doing something scary, like a man-in-the-middle attack. So you need to create you can also generate this randomly, which is what you would do in production, of course. But for now, we'll just set it to this sample pin code. So now we create the accessory, and we now need to create the service for it. And as you recall from earlier in my slides, we only have one service that we need, which is the light bulb service. So and then we'll do. And since there's only one service, since there's only one service, we'll go ahead and just also name it the same as the accessory itself. And now we need to create the characteristic for that service. And we only have one characteristic, and that's the on characteristic. So we're going to go ahead and create a characteristic under that service. So basically now we've created an object hierarchy that's necessary to represent this LED light in the HomeKit accessory protocol. So now we actually need to write some code to actually turn that LED on and off using MRAA. And unfortunately, I don't have that much time to go into how that works exactly, but suffice it to say, we need to basically turn the GPIO pin on the D2, which is where I plugged it in, on and off, depending on whether we want the LED light on and off. So we will create a new object that that embodies that GPIO pin, is D2, since the 2 is because we're plugging into D2. And then we need to set it into output mode, because we're trying to write to that pin, set it at 1 or 0, and we're not trying to read from that pin. And by default, let's when the accessory starts, let's turn the light off. And since we can't actually read from this GPIO pin, we need to keep track of its state separately. We need to, like this in software, we need to remember whether or not it's on or off in software. So we can go ahead and create a separate JavaScript variable for that and set it to false initially because the light's going to be off initially. So now we have to actually let that on characteristic do something with those LED GPIO and the isOn variable. And the way HackNode.js does that is that it has event handlers to take care of reads and write to the characteristic. So the first thing we would need to do is to create a handler for the set event, which will help us handle writes to that characteristic. So the set events has 2 parameters. One is value and one is callback. And the value is going to be the value that the iOS wants to set that characteristic to. And callback is just for us to call back when we're done. So we'll just set isOn equal value. And if they wanted to set it on, we'll write 1 to the LED GPIO pin, or else we'll turn it off. And then since there's no possibility of error, we'll go ahead and call back with we'll call back with no always for the error. And now we need to write a somewhat simpler handler for getting the value, and it only takes 1 parameter, which is callback. And we're going to call back with the first value, which is the error, which no errors can ever happen here. So we'll do no for the first one and isOn for the second one. And now we're basically done. All we have to do is export the accessory, and we should have a working accessory. So you would, I'm not sure if I have a save and proceed. I'm not sure if I'll be able to show you, you'll be able to see my iPhone screen or the LED when that happens, but we're definitely going to try. Okay. Do I have my iPhone over there? Like my larger iPhone, or did I forget it? Oh, no, I have it in the pocket. That's crazy. So I don't know if nobody can see this, but I would just do add accessory, and it shows up over here. And it'll ask me, this is not an official Apple approved accessory. Do you want to add it anyway? I say yes. And then I'll enter the pin code I set earlier manually. And it'll try to pair with it. And then I can turn it on. All right. I'm so happy that worked because I actually had the code written up, printed out somewhere, but I forgot to bring it up on stage, so I was completely writing that from memory. So really happy that worked. So that's it. Thank you guys. That's my.